consider the next method of the differential equation, which is a linear differential equation. So definition of the linear differential equation is what? A differential equation is said to be linear differential equation if dependent variable and its differential coefficients occurs only in the first degree and not multiplied together. The general form of a linear differential equation is dy by dx plus p into y equal to q, where p and q are the functions of x only. So in this case, we have to find integrating factor. It means that if the differential equation dy by dx plus p into y equal to q, this linear differential equation is there, then how to solve? First you find the integrating factor. Means what? That is the integrating factor equal to e raised to integration of p dx. Note that here this is your p dx, and then the solution is y into I of equal to integration of q into I of dx plus integration constant c. So what is the identification of this linear differential equation? In differential equation, you just note if it contains one dy and one more y and there is no another function of y, means it contains function of y only in this y and here dy. And one more thing, there should not be y into dy, then it will be a linear differential equation. Note that the linear differential equation in y is this dy by dx plus p into y equal to q. But if we want to write the linear differential equation in x, then how to write? Then dx by dy plus p into x equal to q, where p and q are the functions of y only. In this case, again the same, that integrating factor you find e raised to integration of p into dy, then directly the solution is x into I of equal to integration of q into I of dy plus integration constant c. It means that here again the same, that if the differential equation contains one y and one dy and there is no another function of y, and one more thing, it should not be in this format y into dy, then it is a linear differential equation in y. Similarly, I can consider here 1x and 1 dx, there is no another function of x in the differential equation and it should not be together, means this x into dx should not be there, then it is a linear differential equation in x. So here working rule to solve the linear differential equation. How? Let's see the steps here. Step number 1, given differential equation you write in the standard linear differential form. What is that? dy by dx plus p into y equal to q, where p and q are the functions of x only. Then step number 2, find the integrating factor. Integrating factor means what? E raised to integration of p dx. It means that you find first the integration of p dx and put here. So I will get here integrating factor. And in step number 3, you find the general solution of the differential equation. The formula is that y into I of equal to integration of q into I of dx plus c, which is your final answer or required solution of the differential equation. Now consider examples on linear differential equation. Example is solve cos x dy by dx plus y equal to sin x. So definitely I will check here whether it is a variable separable form or not. So if you can observe, if we consider this y, it will be minus y, and when we consider this dx there, function of x plus or minus function of y, then definitely it is a not variable separable form. Now whether it is a linear? Yes, because I am getting here 1 dy and 1 y, means 1 y 1 dy, and there is no another function of y, and y into dy is not there, and therefore it is a linear in U. So what is the general form of this? Without fail we should know the theory part of the linear differential equation. And what is that? So this is the general form of a linear differential equation, dy by dx plus p into y equal to q, where p and q are the functions of x only. Then you find I of and then the solution. Okay, now here I want to write given differential equation in general form. First, given differential equation is cos x dy by dx plus y equal to sin x. So I want here dy by dx first. So divide throughout by cos x. Divide throughout by cos x. So what I am getting here? I am getting dy by dx plus what is the 1 by? So here if we divide by cos, so 1 by cos x, it is nothing but sec x. Y equal to sin by cos, it is a tan x. So you can observe here which is a linear differential equation of the form, which is that form, it is a linear differential equation in y. So dy by dx plus p into y equal to q. So what is the p there? If we compare here, I am getting here p equal to. So p equal to sec x and q equal to tan x. After that, what we want to find? We have to find integrating factor e raised to integration of p dx. So that is equal to e raised to integration of sec x dx. So that is equal to e raised to, now what is the integration of sec x? By standard, it is a log of sec x plus tan x. And that is why e and log get cancelled and I am getting integrating factor is just sec x plus tan x. Hence, the solution of the given differential equation is, without fail we should have the theory part. Means here what is the formula for that? It is a y into I of integrating factor equal to integration of q into I of means integrating factor dx plus c. So y into integrating factor is sec x plus tan x equal to integration of what is the q? Q value is tan x. So here tan x in bracket sec x plus tan x if dx plus c. So your integration part should be perfect. So solve this one. Now just integration. So y sec x plus tan x means left hand side as it is. Now here if we separate it, so I will get here sec x into tan x plus tan square x. Now sec x into tan x integration, it is a standard, but what about the tan square x? As we know, 1 plus tan square theta equal to sec square theta. So by using this, I can get here the right hand side, this first term sec x tan x as it is, but tan square x I can write here sec square theta minus 1 like that. And that is why what we get here, here I am getting sec square x minus 1 into dx plus c and here left hand side as it is. And therefore, now by standard integration, I am getting this left hand side as it is and that is equal to what is the standard integration of sec x tan x? It is nothing but sec x plus sec square x integration of sec square x. It is a tan x minus 1 means integration of 1 is x plus c, which is your required answer. Okay, one may simplify more. How? Y sec x plus tan x. So minus sec x plus tan x and plus x equal to c. And I can common out sec x plus tan x. So I am getting y minus 1 into sec x plus tan x plus x equal to c. But not necessary. Now consider one more example there on the linear differential equation. So solution. So how I can say it is a linear? Because it contains one y and one dy only and there is no another function of y, and that is why it is a linear in y. Note that it is not together, means not multiplied together, and therefore definitely it is a linear in y. So without fail I should know the theoretical part of the linear differential equation, but first you write given differential equation is 1 plus x square dy plus y minus tan inverse x dx equal to 0. So first I should have the theory part. What is that theory part? This is your theory part. That is the general form of the linear differential equation in y. Means I want dy by dx. So I will consider dy by dx here. And I am getting y minus tan inverse x equal to 0. Now I want p into y. Means the term which contains only y. So it is there. So remaining right hand side. So what I am getting now? I am getting 1 plus x square dy by dx plus y equal to tan inverse x. Now I want only dy by dx. So divide throughout by 1 plus x square. So I am getting here dy by dx plus 1 upon 1 plus x square into y equal to tan inverse x upon 1 plus x square. If we compare with the linear differential equation, or you can say which is a linear differential equation of the form, which form? That is a dy by dx plus p into y equal to q, where p and q are the functions of x. So here, what is the value of p? P equal to 1 upon 1 plus x square. And what is the value of q? Means right hand side here. If we compare both equations, so I am getting q equal to tan inverse x upon 1 plus x square. Now, by the steps if integrating factor equal to e raised to integration of p dx. So, integrating factor e raised to integration of p dx means e raised to integration of 1 upon 1 plus x square dx, and by the standard integration of 1 upon 1 plus x square, I am getting e raised to tan inverse x. So, hence, the general solution is, what is the formula? Y into if equal to integration of q into if dx plus c. So what is the integrating factor? You substitute here. So I am getting y into e raised to tan inverse x equal to q. What is the value of q here? It is a tan inverse x upon 1 plus x square into e raised to tan inverse x dx plus c. Now your integration part should be perfect. Now we have to see how to integrate it. E raised to tan inverse x. Here one more tan inverse x, and derivative of tan inverse x is present 1 upon 1 plus x square there. It means that we have to substitute tan inverse x equal to t or u, you can say. So here t. So what is the derivative? So what is the tan inverse x? I am getting derivative of tan inverse x is 1 upon 1 plus x square dx equal to dt. And you can observe here, by this substitution, the equation becomes y e raised to tan inverse x. It is outside of the integration, so as it is integration of. Now note here, this is nothing but t. Now 1 upon 1 plus x square dx, that is dt. It means that dx into 1 upon 1 plus x square, it is a dt. And when substitution in the integration, you always find space for dt. If not, I am not getting this one directly, then adjust here. But anyhow, I want value of dt there. And it is a t. So what it becomes? It becomes t e raised to t into dt plus c, integration constant. So now, by UV rule, means integration by parts, we can integrate this one. How? Let's see here. So left hand side as it is y e raised to tan inverse x equal to integration of t into e raised to t. So this is u, this is v. So now integration by parts, or you can use a continue UV rule. So continue UV rule, what is it? It is the integration of uv dx equal to u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus dot dot dot, where dash means derivative and suffix means integration. When we can use here, when u is algebraic polynomial and v is exponential sine and cosine, then I can use this continue UV rule. So definitely here I can use it. So how? So let's see. First constant, integration of second means e raised to t. It is a e raised to t minus the derivative of this t is 1. Now integration of this bracket is nothing but e raised to t, and if we consider plus, what is the derivative of 1? It is a 0. It means that this is finish here, plus integration constant c. Now simplify here, I am getting y e raised to tan inverse x equal to e raised to t common in bracket t minus 1 plus c. What is this t here? Since t equal to, so what is the t here? It is a tan inverse x. So that is why I can get here y e raised to tan inverse x equal to e raised to tan inverse x in bracket tan inverse x minus 1 plus c, which is your final or required answer. So sometimes the differential equation is not linear differential equation, but easily we can convert into linear differential equation. So what is that format? So there are two types. One is Bernoulli's linear differential equation and second is f dash of y dy by dx plus p into f of y equal to q. So one by one we will see here. Reducible to linear differential equation. So sometimes given differential equation is not linear differential equation, but we can reduce into linear differential equation. So in that, the type number 1, that is the Bernoulli's linear differential equation. If differential equation is of the form dy by dx plus p into y equal to q into y raised to n, where p and q are functions of x only, is known as Bernoulli's linear differential equation. So what is the difference between linear differential equation and Bernoulli's linear differential equation? So note that if one y and one dy present in the differential equation not multiplied together and there is no another function of y, then we can say it is a linear differential equation. But additional here for the Bernoulli's linear differential equation, one y, one dy and one more power of any power of y present in the differential equation and there is no another function of y, and note that again it should not be multiplied together, means there should not be y into dy like that. So then it is a Bernoulli's linear differential equation. Now how to solve this Bernoulli's linear differential equation? So note that here what is the additional thing here? Here y raised to n. So divide throughout by y raised to n. So here if we divide by y raised to n, so I am getting here it is a 1 upon y raised to n. So same thing I can write y raised to minus n. So y raised to minus n dy by dx plus p, and here I am getting y upon y raised to n, means what is the power of y? It is a y raised to 1 minus n equal to q. So observe that this y now in the Bernoulli's linear differential equation, it changes by this step as a y raised to 1 minus n. So whatever it changes, that is your substitution. It means that this y changes, so that is your substitution. So what is the substitution here then? The put y raised to 1 minus n equal to u. So differentiate, I want here dy by dx. So therefore differentiate with respect to x. So I am getting here 1 minus n y raised to minus n dy by dx equal to du by dx. You observe here y raised to minus n dy by dx present. That is why value of this y raised to minus n dy by dx equal to 1 upon n minus 1 du by dx. So substitute this in equation 1. So this equation 1 becomes 1 upon n minus 1 du by dx plus p into u equal to q. And this implies that if we multiply throughout by n minus 1, so what it becomes? It will be du by dx plus n minus 1 u. It becomes du by dx plus n minus 1 into p into u equal to n minus 1 q. Note that here this p is a function of x only, q also function of x only, and this is a constant. So I can put this as a p dash and this as a q dash. So p dash equal to n minus 1 p and q dash equal to n minus 1 q. And you observe that I am getting du by dx plus p dash u equal to q dash, which is a linear differential equation, and we know how to solve. So note here it is a linear differential equation in u which can be solved. Don't forget to resubstitute the value of u. What is the value of u here? U equal to y raised to 1 minus n. Now examples on the reducible to linear differential equation. The type number 1. So type 1 Bernoulli's linear differential equation. So here consider example. Solve y dx equal to x dy plus under root of x into y dx. Now I have to check whether it is a linear or not. So solution, given differential equation is y into dx equal to x dy plus under root of x into y into dx. So note that here, if we consider it is a linear or not. So you just see here, it is 1y, okay, 1 dy, and if there is another function of y, so definitely it is not linear in y. Then linear in x, so definitely not. Why? Here I am getting the x into dx or root x into dx, so not linear in x also. Now reducible to linear and Bernoulli, 1y, 1 dy and 1 power of y. So here 1y, 1 dy and 1 power of y, because under root of y means y raised to half, and all are in 3 different terms, not multiplied together. So therefore it is a Bernoulli's linear differential equation. Without fail we should know what is the general form of the Bernoulli's linear differential equation. So I should have this theory part. What is this one? Here type 1 Bernoulli's linear differential equation, it in the form dy by dx p into y equal to q into y raised to n. So I want first dy by dx. If we divide throughout by dx, so I am getting y equal to x dy by dx plus under root of xy. Same thing I can write here, x dy by dx plus root of xy equal to y. Now I want here dy by dx, then p into y, means y term I want second. So x dy by dx minus y equal to minus under root of xy. So this y I will take here, and this root xy I can consider right hand side. So that is why now I am getting, so I will consider here x dy by dx minus y equal to minus root x into root y. Can separate it, and now I want only dy by dx initial, so divide throughout by x. So we get here dy by dx minus 1 by x into y equal to minus. Now note that here I am getting root x upon x, so here x raised to half and here x raised to 1. It means that I am getting in denominator x raised to half, means 1 upon that. So same thing I can write here, 1 by root x into root y. Now this is the Bernoulli's linear differential equation. So what to do in that? This power of y you divide throughout. So divide throughout by root y. It means that it is a y raised to half. We have to divide. So I am getting y raised to minus half dy by dx, because if we divide by y raised to half here like this, it is in numerator y raised to minus half minus 1 by x, and here y upon y raised to half. So I am getting here y raised to y upon root y, or here y raised to half. So I am getting y raised to half there in numerator, and that is equal to minus 1 by root x, and this root y will get cancelled. So what is the substitution there? This y changes now y raised to half. So that is our substitution, and therefore put y raised to half equal to u. I want dy by dx, so differentiate with respect to x. So it is a 1 by 2 y raised to minus half dy by dx equal to du by dx. So here y raised to minus half dy by dx present. So that's why this 2 I can take this side. So I am getting y raised to minus half dy by dx equal to 2 into du by dx. And therefore this differential equation means differential equation 1 becomes, by this substitution, 2 du by dx minus 1 by x into u equal to minus 1 by root x. So it is a linear in u, because 1 u 1 du only, and there is no another function of u. And we should know what is a linear differential equation general form, and that is nothing but here I can consider. So it is a linear in y, so I want linear in u. So du by dx I want, so divide throughout by 2. So I am getting here du by dx minus 1 by 2 x u equal to minus 1 upon 2 root x. which is a linear differential equation in U, which is a linear differential equation of the form. What is that form? Here instead of y now u, so du by dx plus p into u equal to q. If we compare with this example, means if we compare these two equations, so I am getting value of p equal to minus 1 upon 2x, and what is the value of q? 1 upon 2 root x. So now I want to find if, integrating factor. Note that in this differential equation I am just changing y by u, x as it is. Therefore integrating factor equal to e raised to integration of p dx, and that is equal to e raised to integration of minus 1 by 2 x dx, and that is equal to e raised to minus half outside, and integration of 1 by x, it is a log of x. And by the property of logarithm, this minus half I can take the power of x, and that is why same thing I can write as e raised to log of x raised to minus half, and therefore e and log get cancelled, and I am getting integrating factor is x raised to minus half. Means integrating factor, same thing I can write 1 upon root x. So hence the general solution is, it is a linear in u, therefore u into if equal to integration of q into if dx plus c. In this y I am going to change by u. So u, what is if? 1 by root x equal to, what is the q? So q equal to minus 1 by 2 root x into if means 1 by root x dx plus c. So u 1 by root x equal to minus half outside, and I am getting 1 by x dx plus c. So u upon root x equal to minus half. So what is the integration of 1 by x? It is the log x plus c. So which is your answer? But what is the u? Resubstitute value of u here, and u is nothing but y raised to half. So since u equal to y raised to half, and therefore I am getting here y raised to half upon root x plus this minus 1 by 2, I will consider the left hand side. So plus 1 by 2 log x equal to c. Y raised to half means it is a root, so root y upon root x. So now I am getting root of y by x plus 1 by 2 log x equal to c, which is your required answer. Now type number 2, if the differential equation is of the form f dash of y dy by dx plus p into f of y equal to q, where p and q are functions of x only. How to remember this one? How to check it? If function of y and derivative. For example, if there is a tan y, what is the derivative? It will be sec square y. Dy by dx is present there. Then I can say it is a type number 2 reducible to linear differential equation, and very easy to solve. Then put here f of y equal to u. Then what is the derivative of this with respect to x? F dash of y dy by dx equal to du by dx. So this substitution in the given differential equation, it becomes now du by dx plus p into u equal to q, which is a linear differential equation in u. So we can solve it, and then lastly resubstitute the value of u, which is nothing but f of y, which gives our required solution. Now consider the example of type 2, means reducible to linear differential equation type 2. That form is f dash of y dy by dx plus p into f of y equal to q. So solve tan y dy by dx plus tan x equal to cos y cos cube x. So solution, given differential equation is, so what is the differential equation here? Tan y dy by dx plus tan x equal to cos y cos cube x. So here function of y additional on right hand side, so divide throughout by cos y. So I am getting tan y by cos y. Note that what is the 1 by cos y? It is nothing but sec y. Means when we divide by cos, it means that multiplication with sec. So that is why I am getting here sec y into tan y dy by dx plus tan x into sec y equal to, when we divide by cos, so that cancel, so I am getting here cos cube x. And now you can observe it is of the type f dash of y. Function is what here? Sec y. And what is the derivative sec y? It is the sec y tan y into dy by dx. Now it is very clear that is the substitution is what? Sec y equal to u. So differentiate with respect to x. So I am getting sec y into tan y dy by dx equal to du by dx. So by this substitution in equation 1, so equation 1 becomes sec y tan y dy by dx. It is nothing but now du by dx plus tan x into u equal to cos cube x. So I can write here, which is a linear differential equation of the form du by dx plus p into u equal to q. If we compare these two, what is the value of p? So here p equal to tan x. What about the q? Q equal to cos cube x. And we know for the linear, you find integrating factor as e raised to integration of p dx, that is equal to e raised to integration of tan x dx. What is the integration of tan x? It is nothing but log of sec x. So log and sec get cancelled. Now exponential and log get cancelled. So I am getting integrating factor equal to sec x. So hence the general solution is. So what is the formula? Here u into if, because it is a linear in u into if equal to integration q into if into dx plus c. U, what is if? It is a sec x integration q. So q is what here? Cos cube x into if means sec x dx plus c. So since what is the value of u? U equal to here sec y. So u equal to sec y. Therefore I am getting here sec y into sec x left hand side equal to, what is the sec? It is a 1 by cos x and here cos cube x. So definitely one cos get cancelled. And I am getting here integration of cos square x dx plus c. How to integrate cos square x? It is a 1 plus cos 2x by 2. And that is why 1 by 2 integration of 1 plus cos 2x left hand side as it is. And I am getting here sec y sec x equal to 1 by 2 by standard integration of 1. It is a x plus, what is the integration of cos 2x? It is a sin 2x upon 2 plus integration constant c. So same thing I can write as sec x into sec y equal to x by 2 plus 1 by 4 sin 2x plus c, which is your final answer. One may simplify more, means these terms we can take left hand side, but not necessary. Or you can consider the answer up to this only.